The rules we're learning today are basically what you would expect them to be for adding, subtracting, multiplying, and dividing with functions. If you're adding two functions, you just add them. If you're subtracting two functions, you subtract them, and so on. So let's look at example 1a, and we're going to add function f and function g together. So we're basically going to write down the function for f of x, which will be all of that, and we're going to add to it, because this is an addition problem, the function for g of x. So all of that. So let's write down the blue one, 2x squared plus 4x minus 6. We're going to add 2x minus 2. Now what else I'm going to do is I'm also going to put these each in parentheses so I can remember which one was the blue one and which one was the red one, just in case I wasn't color-coding them. So let's go through and combine like terms. I'll look for all the x squareds first. I only see those two. 2x squared. Alright, next I'll look for all of the x's. I have 4 here. I'm going to add on 2 more there. So all together, that's 6 x's. And last, I have the plain numbers. I have a -6. I'm going to add to that -2. So -6 plus -2 is -8. We don't have any like terms to combine, and so that's the final answer. Alright, same thing. But now, instead of adding the functions, we are going to subtract them. So we're going to take the f of x function. We're going to subtract from it the g of x function. So I'll have, in parentheses, the blue one, 2x squared plus 4x minus 6. And I'm going to subtract from it, in parentheses, the red one, the g of x, 2x minus 2. Alright, so if you remember subtraction problems, we said that you can rewrite the first part that's in parentheses, and now we're going to flip all the signs that come after this minus sign. So instead of having this positive 2x, we're going to make it a negative 2x. And instead of having this minus 2, we're going to write plus 2. Now we can go through and combine like terms. So I don't have any other x squareds. I have 4 x's, and I'm going to put that with the negative 2x. So 4x minus 2x is positive 2 x's. Last, I'll have the -6 plus 2, which will be -4. And that's the final answer. Next, we're going to multiply. We're going to multiply the g function by the f function. So this will be g of x times the f of x function. So the f of x one will be the red one, and the g of x one will be the blue one. Now for multiplication, if you think to yourself, does the order really matter? Is 2 times 3 the same thing as 3 times 2? Yes. So it doesn't really matter which one we write down first. But because of the order of this problem, I'll write down the g of x function, the blue one, first, and I'm going to put it in parentheses. And I'm going to multiply it by the f of x function, the red one, also in parentheses. So if you learn anything today, it's to put your functions in parentheses. So it looks like we have ourselves a 2 by 3 problem. So I'm going to go ahead and draw a 2 by 3 box. If you like doing FOIL for these kinds of problems, that's fine. I'm going to do the box way. So I have 2x and -2 on the side, because that comes from right there. And on the top, I'll have the 2x squared, the positive 4x, and the -6. Now I'll go through and multiply. 2 times 2 is 4. x squared times x to the first is x to the third, because we add up the exponents. Next, 2 times 4 is 8. X to the first times x to the first is x to the second. And 2 times negative 6 is negative 12 with an x. All right, bottom row. Negative 2 times 2 is negative 4x squared. Negative 2 times 4 is negative 8. And there's just one x there. And last, negative 2 times negative 6 is positive 12. So let's go through and combine like terms. We have 4x to the thirds and no more x to the thirds. It looks like these x squareds can be put together. 8 minus 4 is 4x squareds. It looks like these x's can be put together. Negative 12 minus 8 is negative 20. X, and finally we have that positive 12. So that's the final answer. Now for the division problems. We have the f function on top and the g function on the bottom. Does it matter that we actually put the f function on the top? Yes. If you think to yourself over here in a little bubble with the other part, is 3 over 2 the same thing as 2 over 3? No, it's not. So don't do that. Make sure you put the one that's on top, and the one on bottom, on bottom. So let's go ahead and, now we have the blue one being the f function. So we'll write the blue one, 2x squared plus 4x minus 6 on top. And underneath it, we'll write what's now the red one, the 2x minus 2. So we need to be able to cancel some things out, but we can only cancel things out when they are multiplied together. Remember how you have to have factors, the same factors on top and bottom, in order to be able to cancel out? So we need to factor the top and factor the bottom. Number 1 rule when you are factoring is to find a greatest common factor. The number 1 thing we have to do. So let's look on the top. Is there a GCF we can pull out from all 3 of those? Yep, we can divide them all by 2. If we do that, we'll be left with x squared plus 2x, because 4 divided by 2 is 2, minus 3, because 6 divided by 2 is 3. All right, let's do the same thing on the bottom. Is there a GCF on the bottom? Yes, it's 2. So 2 divided by 2 is 1, 1x, and then negative 2 divided by 2 is negative 1. All right, now that these 2's are both multiplied on top and bottom, we can cancel those out. We have one factor on the bottom, but we can further break that top down into 2 more factors. See how that's an x squared? So those 2's are gone, and we're going to break the top into 2 factors. We still have that x minus 1 on the bottom. I'm just going to recopy that. Hopefully we get an x minus 1 for a factor on the top. So let's see. I know we'll have x and x. We are looking for the factors of 3 that subtract to give us positive 2. So the factors of 3, our only options are 1 and 3. How can we subtract those to get 2? Well, if we put plus 3 and minus 1, that will work out for us. And it just so happens that since we have the x minus 1 and the x minus 1 on top and bottom, those cancel each other out, and the only thing we have left for our final answer is x plus 3. Sometimes problems will work out really nice and you'll have a bunch of stuff that cancels out. Sometimes it won't, but this one worked out well. Compositions of functions. It's kind of like a 2-in-1 problem. It uses the output. You can fill in output right there. The output is just a fancy word for the answer. From one function as the input, or in other words, what you plug in to the second function. So just like when we learned order of operations, if we have a bunch of things inside parentheses, you work from the inside out. I would jot that down on your paper. So let's look at 3a. You read this as f of g of 2. So basically when you see the parenthesis, you say the word of. So I'll read that one more time. This is f of g of 2. So we're going to work from the inside out. I'm going to make the g function red, and then I'll make the f function blue. Alright, so there's the blue one, and there's the red one. And so first, we're going to do what's on the inside, and the g is on the inside. So first, we're going to figure out g of 2. So we're going to plug in 2 to the g function. The g function's x to the third, so we're going to plug that 2 in, and it's going to be 3 to the third. Oops, not 3 to the third, 2 to the third, because we're plugging in 2. So it's 2 to the third power, which equals 2 times 2 times 2, or 8. If that was the only problem we had here, we'd be done. 8 is the answer to the first function. So we're going to take that, and we're going to use it as the input into the second function. So now we're going to move to the outside and use the f function. And we are going to plug in the 8. So let's write down the f function. It's 3x plus 1. And since 8 was the answer to the first part, we're going to take that 8 and plug it in for the x and the f function. So this will be 3 times 8 plus 1. So 3 times 8 is 24, plus 1 is 25. So even though this 8 was an answer before, it's not our final answer. Our final answer is the 25. Let's do 3b. If you notice, the only difference between 3a and 3b is this time the f is on the inside and the g is on the outside. So let's work from the inside out, and first we're going to take 2 and plug it into the f function, which is 3x plus 1. So we're going to take the 2, plug it in, 3 times 2 plus 1. Well, 3 times 2 is 6. 6 plus 1 is 7. Alright, so we're going to take that blue 7 and we're going to plug it into the g function, which is, alright, so it's going to be g of 7 because we just got 7 for the answer. The g function is x to the third, so we're going to take that 7 and plug it in. So this will be 7 to the third. It's going to be a pretty big number, 343. So that's the final answer. That first 7 was just on our way to the answer. The 343 is the final answer. For your assignment, I changed it so you only need to do numbers 2 through 10. So kind of ignore this 2 through 13 and just do 2 through 10. All right, good luck.